Is there anyone who is here from the start? Am I audible or not?
Audible, sir.
Yeah. This time I have to start. Fine. Okay, screen is visible, right?
Yes, sir.
So, so anyone can define what is pure substance? Hello. In the first class I have told, right?
Substances that have same chemical composition.
Mhm. So here it is saying like their substance with constant chemical composition. Okay, so it should not change, right? With the place to place like that. So here we have, what we have to do, properties of pure substance we have to study. So what are the properties uh, in thermodynamics? What properties we have till now encountered, like pressure, enthalpy, entropy, internal energy. So like that we will be dealing. So first of all, any substance we will take, and when we will be giving heat, like for example water we will take. Okay? Water. So when we will be giving heat, then what will happen? Its temperature will rise, and ultimately it will convert it to the steam, right? Hello. Hello.
Yes, sir.
So what happening here? Phase change is happening, right? So phase from where to where? Liquid to gas. Liquid to gas it is happening here. So when we extract heat from this water, then it will become solid. So now I want to know like how properties are changing with varying pressure at constant pressure, and what are the property when it will be in solid, what would be the properties when it would be in the gaseous phase or at the liquid or mix of both. Any correct getting what we are going to do here in this session. Hello.
Yes, sir.
Okay. So now first of all we would be knowing getting some diagram like PT diagram you would have seen for various things like this way. So here and this line what it shows, solid plus liquid, and what this line shows, vapor plus liquid. So this is triple point.
Sir, did you start recording?
Yeah, I will start. So my question is like for water you will be knowing there on decreasing temperature, so its a volume from 0 to 4. When what happens for water from 0 degree Celsius to 4 degree Celsius? When increases temperature, it volume decreases, right? Hello.
Yes,
Yes,
sir.
sir. Volume decreases after that the volume increases
Uh,
4 degrees
it
Celsius
is
to
for
0.
only for water, right?
Yes, sir, yes, sir.
In other things, when temperature increases, generally volume increases. But this phase diagram is for the when from this is the feasible part for this, na? Solid to liquid conversion is. So here it is valid for when volume increases with temperature increases. Means when temperature increases, volume increases, then it is like that. But what happens when volume decreases? Yes, temperature decreases. Sorry. So here what will happen? This curve would be like sun, and here it will come like this. So my question is like, can anyone prove how why it becomes? Why it becomes? Just think 1 minute and let me. Got my question or not?
Sir, can you please repeat?
Hello. Hello. Anyone? Some people have said anything. What are saying?
Sir, please repeat the question.
Okay, okay. So I'm saying like there are two types of substances. Like one when their volume increases when temperature increases, and another one its volume contracts when temperature increases. So for this, for second one, that volume decreases with temperature increasing in temperature is example is water, right? And normal any other substance, their volume will increase with increase in temperature. So I'm saying like the phase diagram pt curve uh, for the substance their volume increases with increase in temperature is like this. Means this is the solid to vapor, means here this transformation is taking place, and here liquid to vapor, and here solid to liquid. So solid to liquid their slope is this way, and for the substance having that those contracts with increase in temperature is uh, slope is this way. Difference is clear or not?
Yes, sir.
So my question is why it is like that? Now clear?
Yes, sir.
So if anyone remembers like this is which curve? PT curve. Last class any questions you would have seen with a PT? Yes, dp by dt, or sorry, dp by dt or dt by dp, like this way. Any question you know? Remember any person who were attending the last class? Joule Thomson coefficient, anyone remembers?
DT by DP, sir.
Means this way, na? Change in temperature with pressure. So anyhow,
Yes.
slope of this like ways. Hmm? Its axis got changed, but here we will get those things, right?
Okay, sir. Okay.
So just try to see that formula. Maybe some people are new here. So anyone remembers that formula, or hello? This is correct. Joule Thomson coefficient. Visible or not?
Yes, sir.
So what is this? 1 by Cp T del V by del T at constant pressure and minus specific volume. So what is this? And del V by del T means change in volume with a change in temperature. For water, what is this? Volume decreases, right? When temperature increases. Correct or not?
Yes, sir.
So this time would be negative, correct?
Yes, sir.
And this is already negative, so negative means slope would be negative, means dt by dp, or reverse you do dp by dt, both would be negative, correct?
Yes, sir. Negative.
So Joule Thomson coefficient for water would be negative, means any substance whose volume decreases with increase in temperature is negative. So coming to the our point here.
Sir, but why del V by del T for water is negative?
This is already we knows na, from 0 to 4 degrees Celsius volume contracts for the
Okay, okay.
when we increase the temperature from 0 to 4, its volume decreases, we know na this thing.
Sir, but for other substances,
Other
which
is
is
different na, that's why that was the question na. Other this graph would be like this. So this graph, it's a slope, what slope is positive, right? When increase
yes,
in temperature, its pressure is increasing, vice versa, when pressure is increasing temperature is increasing, correct?
yes, sir.
And here it is reverse, means its pressure decreasing, means its pressure decreases when temperature increases, opposite also you can say. Pressure decreases while temperature increases. So clear now or not?
Yes, sir.
So these things I may ask, like which graph is for the water pt curve, correct? Should I
Yes,
proceed now?
yes, sir, sure.
Now pt curve is over. Now coming to the pv. So in curves, in these curves, I would be telling like which are the main key points. There you may commit mistake. Only those points I am telling. Okay. So for the PV curve, this curve is like this. So here, like constant pressure line, if we draw, constant pressure line would be like this, correct? Hello.
Yes, sir.
Yes, sir, yes, sir.
So this up to this is triple point here. So up to here, my question is like whether this would be the correct graph or this would be. Sorry. Which one is correct? Anyone?
First one.
Why?
I don't know, sir.
Sir, more pressure is required for a small volume change in case of solids.
Let's suppose this is
Sorry, liquids.
liquid and this is so liquid we consider as an incompressible fluid, right?
Yes, sir.
So incompressible, what is meaning of incompressible? Like it's a volume change in volume when apply change in pressure. So it would be tend to zero. Means it will never be like zero, but it close to zero. So then we will say like it is incompressible. Generally we would say like if this value is 10 to power minus 3 minus 5, so then we will say like okay, it is incompressible. So which for liquids here what it is showing, when we change a small amount of pressure, like suppose this is the change in pressure. So when what how much volume it got changed, this much, so it is sufficient. uh, Means sufficient volume change when applies pressure for liquid, but it is not so na. So this won't be there. So for the pv curve, this is the saturated liquid line. So for the saturated liquid line, this curve would be very steep, means close to vertical, means okay. So this like that way you can justify this. So for PV curve, this is okay. we will usually draw the TS curve. So constant pressure line at the TS, this would be like this: P is equal to constant pressure line. We'll draw like this. Okay. So this is the just saturated liquid, and here it is vapor, and in between liquid plus vapor is there. So now for the property steam table we are having, so there we will be knowing the properties at this point, and we will be knowing the properties at this point. Hello. Hello.
Yes, sir.
Ah, okay. So in between, we will define a one factor dryness fraction. Anyone knows what is dryness fraction? Hello.
The
Fraction
mass of
of
vapor divided by the mass of
What?
liquid.
fraction of vapor.
Fraction of vapor. Anyone? Is it correct?
Sir, friction of vapor present in a liquid vapor mixture.
Hmm. Means it is the ratio of the mass of vapor present in the uh, mass of vapor to the total mass of the system. Correct? Mass of vapor divided by mass of total means mass of vapor plus mass of liquid. Correct? We will define dryness fraction as x. So means we will be knowing the properties of the saturated liquid and saturated vapor. So if we know this ratio, so then we can easily find. Let's suppose I would say like rule of mixture, just simply like one thing is there, means ice, you suppose it is ice and it is water, normal. Hmm. Ice at minus 10 degrees Celsius and water at 60 degrees Celsius, and it is 5 kg and it is also 4 kg. Now you can mix both these things and you can easily find the resultant property, right? Mass balance, energy balance, both do and find. Correct or not?
Yes, sir.
So same thing will happening here. Like we would having something here, like we whatever mass we are having, that we have completed converted to complete thing, and here we have just to find the fraction, how much what fraction of vapor is there. So we will take the property and multiply with that fraction for with the vapor, and take the fraction of mass and multiply that with the mass. So like way we will derive here. So for any property, one property I will write like at any point here. Let's suppose fraction is mass, the dryness fraction is x, so h at x would be hf. Here all properties at the this fusion curve I will write as f, and here we will subscript I will provide as g. So hf plus x hg minus only hg. If hg is given, but generally what they used to give, the difference of this they provides. Getting or not getting? This vapor and saturated liquid. So we will define that as hfgh hg minus hf. What is hg? Enthalpy at the saturated vapor phase, and hf is enthalpy at the saturated liquid zone. So hg minus hf. So like that all properties you can write. In between all property we will be knowing h u also same way you can write, v also we can write, and s entropy also we can write same way. And what other property we can find from here more? Whatever remaining are there you can easily find. Now my point is like if you have to find the what is the entropy here, this point. what is the entropy would be here at this point? Can anyone tell? How will you find?
Yes, sir. In this before the saturated liquid line, it will be less than the saturated liquid that is SF minus.
1 minute. We will say this is A and this is B. So what would be SA?
Sir, SF minus
Hmm.
CP of liquid
Hmm.
and natural log of T saturated upon this TA.
We will say TL. We will say T by TL. Anyone? Any doubt here? How it came? Like, hello.
Sir, can
No,
you,
sir, it is fine.
sir, can you write this term by the SFZ equal to SG minus SF?
Same way I have written. I told for enthalpy, but same way valid for all. Okay.
Okay.
So it is okay na for everyone.
So, the pressure term is cancelled, isn't it? Music.
Because constant pressure line, so P by P would be 1, so ln1 would be 0. That term got cancelled.
So one more thing. Initially, we were having an three lines in that is solid, liquid, and vapor. So how do we get this dome? Like only.
No, no.
Uh,
It is now we are only at the that liquid vapor. All we have left. Huh?
so we excluded the solid part.
This part only we are focusing. Okay.
So that portion is taken as dome.
Uh-huh. Here
Okay.
this here what is there? So only one more question here. Like triple point here would be what is the value of triple point? Anyone knows? Pressure at triple point.
For water, sir?
0.611
Ah,
kilopascal.
0.611.
0.61
Ah,
kilopascal something or megapascal.
kilo.
Okay.
Temperature at triple point would be 0.01 degree Celsius. It is fixed, right? Because degree of freedom when we found in the first class it was 0 for the triple point. Anyone remembers or not?
Yes, sir. Yes, sir.
Okay. So when we try to draw the triple point line here, so pressure is constant, correct? So when constant pressure line 0.611. So when we try to find 1.11 line, let's suppose this is the point pressure 0.611 kPa. So how this line would be drawn? Like this way, right? Straight line. Getting or not getting?
Yes, sir.
Yes, sir. Yes, sir.
So this triple point temperature is only for water, isn't it?
It is these properties for water only.
Okay.
Sir, can you kindly repeat about triple point?
What this line shows? This line shows the equilibrium of the solid plus liquid. Two things. This line. And this line shows the equilibrium of the vapor and liquid. Correct? Suppose 1,
Yes.
2, and 3. And the third line shows the equilibrium of the solid plus vapor. But this point which shows the equilibrium of all three. Solid, vapor and liquid. Hello.
Yes, sir.
Sir,
So
line 2.
what line 2?
The point where meeting is.
No, nothing. Point. That's why I am saying here. Here pressure is constant for triple point and temperature is constant. Why? Because degree of freedom when we found from the Gibbs phase rule, P plus F is equal to C plus 2. So water component is 1 because H2 only we are using. So phases at triple point, how many phases are there? Solid, vapor, liquid, all three are there.
Vapor
Right?
and liquid, yeah. Yes,
So
sir.
P would be 3, F 1 plus 2. So F becomes 0 from here. What F shows? F shows the number of independent variable requires to locate that point on any means fix this position. So how many variables you needed to fix this position? 0. Means we don't need it is already fixed. So that's why pressure and temperature is defined. So fix it is fixed for this. So we know these values. So now for the P also fixed, T also fixed. So it would be the point on the PT curve, because in any graph when we two axes are there and two variable both know that would be the point is there, right?
Yes, sir.
So it is point here, but same way here volume is don't fix volume is not fixed for this. So here pressure 0.611 fixed, but volume may change. So 0.611 when we draw it is line. For temperature 0.01 here. So convert to degree Celsius or like way 0.01 we draw here. 0.01 degree Celsius. So it would also be line here. Correct?
Sir, specific volume not being fixed means like we can have any composition of.
Volume because here gas is also there, na? Because all three things, so solid, vapor and liquid. So for the temperature pressure is same, but if its composition got changed, so volume will increase from here. Got it, no? Pressure would be same, but volume increased. Means some part of this, some part of liquid came and converted to vapor at the triple point. So volume changes, but temperature pressure won't be changed. Getting or not getting?
Yes, sir.
So because that's why here entropy and this volume all not constant. These may change, but these things pressure and temperature is constant. So for the PT curve, triple point is the point. So this also may be asked as question, in which curve the triple point is denoted as a point. So you will be knowing like it is PT curve. So it would be the line at the PV, TS, in all curves it would be the line. Okay.
What about enthalpy in triple point?
Enthalpy also you can say like enthalpy is nothing but in enthalpy we used to do only multiply Cp here. If we multiply T with Cp, then what will happen? It will become enthalpy, right? But always enthalpy Cp is not constant, so it may vary. Getting or not? Means you just not simply Cp is constant we consider and multiply.
Yes, sir. But if Cp is not constant because of phase change, in enthalpy will change.
So that's why that next graph will come. HS Mollier chart.
Sir. Hello.
Hello.
Yes, sir. Sir, in the TS diagram, won't the triple point line will lie only inside the dome, because outside the dome the pressure changes.
This curve will come downside also. And here then again because here triple point we are showing now, so here after this solid would be there. So that is the separate part. Solid, so, here liquid, and here vapor. Like
this line goes to like infinity.
Which line?
The triple point line.
Entropy would be, you can't restrict the value of entropy now.
Okay,
so
okay.
It would directly go like that.
Okay, sir.
So same way you can find the entropy here at B point, right? Entropy means we will draw again. A1. So entropy at A is what is? Anyone? Hello.
Yes, sir. Yes, sir. Yes, sir. Please repeat.
So how you will calculate the enthalpy here at SA, HA, if you have to find?
Sir, it will be H1 minus Cp, T1 minus Ta.
Correct for all, no? Hello.
Yes, sir.
Because these things we will be using in questions. Just after that I will we will solving question. No more formula here. So same for this. Here what will be H2 plus Cp of vapor. Just keep in mind here liquid and this vapor, Cp would be different. Okay, Kb minus T2. This would be the
Sir, for liquid and vapor, we are considering the Cp is constant, sir.
That would be mostly given. So this formula keep in mind.
सर प्लीज आप रिपीट कर देंगे एच ए से, क्योंकि वो गलती से डिस्कनेक्ट हो गया था.
H is nothing na. Here constant pressure line. So constant pressure line, what would be the enthalpy here at a, if T it is TA, it is T1. So H1 is here, and this H is H1 minus Cp delta T, simply because constant pressure temperature is dropped. So how much enthalpy heat you have extracted from that? This part would be we subtract, and here this, because here we are increasing this much temperature. So here just added. Got it?
Okay sir, yes sir, thank you sir.
So now I will show for HS curve only. I want to tell only one thing here. We know dH is equal to TdS plus VdP, correct?
Yes, sir.
So for example HS, this is the same. So for the constant pressure line we want to draw, so VdP would be 0 there, right? Hello.
Yes, sir. Constant.
For the constant pressure line VdP would be 0.
Yes, sir. Yes, sir.
So for slope dH by ds, so what would be the dH by ds here? Temperature.
0. Yeah, temperature. Yes, yes.
So here if we try to make this line, so what would be the slope dH by ds? Means in subcooled liquid, subcooled region, means its temperature keep on increasing with time, right? When you are heating. But it is correct or not? You just anyone can tell or not?
Wrong.
And next example you can draw this way. Three graphs I am making. One this, and second this, and third. First, second, third. Now got this would be the our direction. So anyone can suggest which I can fit here?
2.
Or any other option? Any other person? Hello. Question is clear or not? What I'm saying?
Please repeat the question.
I'm saying
No, sir.
slope of the dH by ds in molar chart HS curve, slope is temperature. So in subcooled region, when we are heating giving heat to the water, so what would be the shape of the curve here?
Slope will be increasing, sir.
Slope will be increasing, right? So which part three options we are having, means we have to go this way from here to here anyhow. So
sir it will be second one.
so only
I
here it
think
is slope it's increasing. So initially what I made it only straight line I draw. So that was wrong that way. So this way you have to make. Hello.
Yes, sir.
Yes sir, yes sir.
And inside the dome temperature is constant at the phase change, right? So it would be the straight line, and again same way. Sorry. Again here slope will increase, right? And now I want to tell like one more thing. Here it will go like way. So here how it will go, like this way, or means it would be a straight line this way, or Means it is diverging. I want to tell that only because it's what ever this pressure would be more. Like one example is this. Here. So it would be diverging in nature, right? Because its slope would be more than this. Means like 1, 2. So T1 would be more than T2, correct? It is clear, na?
So the slope is increasing because the temperature is
No, no,
rising.
it is not the region here. Here region is like because at higher temperature, its saturation temperature will increase, right? At higher pressure. Means if pressure increases, then saturation temperature will got increase, right?
Okay, sir.
So same way, here pressure increases, then its temperature will increase. Temperature increases means its slope should be more. So its slope would be more. Slope R1 would be highest, second in mid, and third in between. So in curves, you may commit some mistake. So it will not be that asked, but if I ask, then they are keep in mind that I will use. Okay.
So here we are only considering the constant pressure lines. So do we need to consider the uh, constant volume in TS diagrams?
In
We are only,
TS.
yeah.
Yeah, yeah. So here in TS, what you can do like TDS is equal to du plus PdV, we can say. Correct. But here you have to here we du you have to write like CVDT. But here also next problem what will come, we don't know like CV is constant everywhere or not. Huh? Getting or not getting? Because here you what you want to at least at the end you want dt by ds. Constant volume you can make it 0, but when you try to make dt by ds here, but it will become t by cv. Correct or not?
Yes, sir.
So problem here it would be like a cv constant or not. We assumes it happens, but practically may not happen. So that's why if you are going to make the curve for the du by means us, then it is okay. But practically it is not used.
The constant volume lines are not used.
Yeah.
So the constant volume lines are not, we are not using any constant volume lines like.
No. Our all practical purposes are finished between these curves only, so we are not going for that.
Okay, sir.
So, sir, what was the reason that you told for the divergence of the lines in the curve?
So just
Dome?
simply see the slope is there, na? Saturation temperature will got increased when pressure got increased. So if saturation temperature increases, then what this slope would show? It's saturation temperature, and if saturation temperature is high, then its slope would be high. So any line you draw here like this and this.
Okay, sir. Yes, sir.
So it's a there should be divergence if the slope is increasing. Okay. Now we will solve some questions.
Sir, one small doubt. So can you kindly represent this triple point on HS diagrams?
HS. In for these all these things for all apart from PT curve na, HS for triple point is it is like here it will come, and here we will define one boundary and line it will be like this, and here we will use to say solid, and here liquid, and here vapor. So means this dome will got shifted. It is not like it is the point. Okay. So whole line represents here particular point.
Here also it's line only, sir.
For all apart from that everywhere is line. Means if both axes are P and T, only that way we are going to make as it triple point. Only this curve we can make, na, because pressure is fixed and the temperature is fixed. Here
So
only
in
it will.
HS diagram, triple
HS,
point
what?
has the slope or not?
What?
Like in the HS diagram.
It won't be straight line. Means
Okay.
directly parallel to axis XY. It would be
Okay.
some slanted one. Something would be there. Because these two lines should show like zero axis. Means its value should be 0. And a triple point value also is close to 0, 0, 1. So we can say like this way. Getting or not getting?
Yes, sir.
So this way we can say. So first simple problem we will start, and after that we will start. So 1 minute you read, and I will start after 30-40 seconds. Anyone if he is getting how to solve, he can explain me, okay? And everyone have calculator along with you. Hello.
Solving, sir.
Okay. Anyone can explain how to proceed this problem?
First, finding the specific volume.
Specific volume is given. Small, if anything in small, then it is specific. Okay. Specific volume at
Sir,
the
specific volume at the mixture.
So we can multiply the specific volume with the specific volume of water with the mass of water plus
Yes.
vapor specific volume into mass of vapor.
Sir, we have total weight 10 kg, and the weight of the liquid is 8 kg. From here we can get the weight of the vapor, that is 2 kg, and we have a VF
this with this and
by multiplying
multiplying it
this
with
and
this. Correct?
yes, sir. Yes, sir.
So how much is the final answer? If anyone have not got how to solve, then I will simply solve. What would be the final volume? It would be the mass. What we and if anyone have doubt, what is small vf? Let me know. Specific volume everyone knows, right? Hello.
Yes, sir. Yes.
So Vf is the specific volume at the saturated liquid, and Vg is the specific volume of the saturated vapor. So we know the mass of the liquid is 8 kg and mass of the vapor is 2 kg. So when we want to know the actual volume, just simply multiply the specific volume with that corresponding mass. So mf into specific vf and plus mv, right? Mg also you can write mass of gas and vg. So when we do this, 8 into 0.001036 plus 2 into 2.3593, and directly we will get the value. Now if I have written here like vfg, then what to do?
Sir, we have
Anyone?
Then x, then sir x से multiply करेंगे vf plus vfg के into x.
Anyone? Other?
sir, we have VFG. From here, we have from subtracting VF from VFG, we can get VG directly,
Means
and
like
we have
vfg is equal to vf minus, sorry, vg minus vf. So we have to find Vg here. Just simply add the value of Vf in the Vfg value. Correct?
Yes, sir.
So then use. So keep this in mind. Okay. Here it is not so. So we directly used.
Sir, one doubt.
Uh-huh.
Sir, can we consider this as wet vapor?
Yeah. So that this is the one way to solve that problem. So you are saying like we will be considering as wet vapor. So first you have to find the dryness fraction. What is the dryness fraction here?
0.2, sir.
0.2. Correct? Hello.
Yes, sir.
Yes,
Yes,
sir.
sir.
So V at 0.2 would be, what formula we have written? V at x is equal to Vf plus x Vg minus Vf. Correct? Hello.
Yes.
Yes, sir.
Yes, sir. Yes, sir.
Simply write this. But here what you will use as Vf?
Specific volume.
No. Now not now you need not to use specific,
0.001036.
Oh.
because now we are going for the final one. Or what?
Volume of 8 kg
Which we have
liquid.
to use, final or specific?
Final.
Sir, if we are taking this specific Vx, then we will use this specific one.
Specific everywhere, right? That I want to know. So here what in the final result we will be getting meter cube per kg. So at that point that V.2 would be the total mass would be 10 kg. So we will every property would be here specific, and finally we will multiply 10 there. Okay. So simply put this Vf plus 0.2 and here Vg minus Vf. So anyone solved by this way? How much it is coming?
Yes, sir.
4.7.
4.726.
No, just a specific value. 4 point what was
0.4726.
4726. Okay. So multiplied by 10, it will become 4.726. So it would be meter cube, and here also it would be same, I think. Anyone solved by this way? Just multiply this and let me know.
Both answers are same, sir. 4.7269.
Sir, if we are calculating a specific volume, finally we should just multiply by the total mass.
Simply because here specific volume is what, meter cube per kg. How much meter cube is in 1 kg? Then if you give the mass, then total meter cube you will be getting, right?
Here we need not consider individual mass like 8 kg, 2 kg.
No. Here directly we are trying to find what volume of this total mixture. Here we are considering already known, because 10 kg water they have given, and here you know like 8 kg is in the liquid and remaining 2 kg is the mass. So it would be it has already said here it is 8 kg of this and sorry, opposite. No, this much. 8 kg of this and 2 kg of this. So it would be in between this, right? Because in total system, what is 8 kg of this part and 2 kg of this part. So average will be in between, right? Hello. So we already know like it is in the wet area. So dryness fraction we found, and simply this value we are knowing and this value we are knowing, and found the final value. Correct? Clear or not clear?
Yes, sir.
So just anyone can explain how to proceed this problem? Hello. Just try first. Then
Yes, sir.
Anyone? Just
Sir, first finding out the specific volume, as say it lies between Vf and Vg, so it is under vapor dome. So pressure will be 2.547 megapascal.
how you did that find? 1 minute again.
सर मतलब स्पेसिफिक वॉल्यूम की वैल्यू फाइंड आउट कर ली, वॉल्यूम ऑफ द टैंक बाय मास ऑफ द लिक्विड.
Okay, 1 minute. Small v means it is 0.005 meter
which lies between Vf and Vg.
So here, how you came to know like all it is liquid means this is the volume. You just simply divided by the mass of liquid. I don't think it is correct.
Sorry, sir.
Any other? Okay. Should I wait or I start?
You can start.
So first we have to find like here we know this is the mass of the liquid they have provided, and here we know the specific volume of this specific volume of the liquid we are knowing. So we just multiply this, then we will find like what is the volume of the liquid only. So how much it would be? Multiply it. 0.01199 meter cube. Correct? Getting or not getting? Vf multiply with the mass of the liquid.
Yes, sir.
Yes.
Mass of the liquid is just 10 kg. It is mass of liquid is 10 kg. So volume of liquid we knows, and now simply now we came to know like okay it is mixture of the liquid and vapor. Correct or not correct?
Yes, sir.
So if it is like less than this, then
What, sir? What?
my meaning is like if this we multiplying after this and this, and vessel volume is this, and its value become less than this, means 0.03, then simply it is a complete liquid, right? Means volume is this and here liquid is there only. Correct or not correct? So nothing is above that. Now it's completely filled. 0.05 means some gas is there, only that it will occupy this place. Correct?
Yes, sir.
So if volume, so how much vapor is there? Volume of vapor anyone found? Volume of gas. So it would be 0.05 minus 0.01199. How much it is coming?
0.48801. 0.488.
4.488
01
meter cube. Now
That is mass, sir.
now mass of the vapor. Anyone can tell? Point here how it will you find mass volume of the vapor divided by specific volume of the this. Correct?
Sir.
Hello.
Yes, sir.
So how much it is coming?
So VG is wrong.
Oh, yeah. How it will come like this?
Yes, sir. Yes, sir. It's actually
How much? 0.03 something it would be. 0.03.
8. 038.
Okay. 0.038. Now this is correct, right? Okay. So what is the mass of the vapor?
Point 484.
Okay. So now we are knowing the here what is our aim here? We have to find the all properties here because specific volume, enthalpy, entropy, internal energy, everything we have to find. But for finding these properties, we need to find the dryness fraction x because only we know it is the mixture of the liquid and vapor. So if we don't know the value of x till that point, we will not be able to find all these properties. So our aim is to find the mass of the liquid we are knowing already, but we have to find the mass of the vapor. So mass of the vapor also means mg. I'm writing here. So mass of the vapor now we knows. Mass of the liquid is 10 and mass of the vapor is 0.484. So easily you can find x now, right? Mg by ml plus mg. So what is the value of x?
0.046.
046.
So it is the in between. This is the dome and like that. So if it is this, so it is in between this. So it's a pressure would be this, right? Saturation pressure. Constant pressure line is this. So it is in between this. So pressure is simply we can write 2.5477. Now specific volume you can find, right? Because we know the value of x. Hello. Hello.
Yes.
So I think we need not to wait here. If anyone had doubt, then we can solve. Otherwise, we know all values here because VF VG we knowing specific enthalpy you can easily find HF HG both values are given here. Correct or not?
Yes.
Entropy also you can easily find. You would be committing mistake if here it is like HFG. That point if you in the hurry and then you can commit.
Sir, for find the mass of vapor, sir, we can find via the formula of volume of vapor upon specific volume.
That same thing we have did.
Okay.
That volume of the vapor, volume of the vapor we found first and we divided by the specific volume.
Okay.
So now I would say like it is not given the problem. Then you have to find the internal energy. Then anyone can suggest how you will find. Let's suppose it is not here. Not here.
So we can use H is equals to U plus PV.
So it is valid here, okay? So this keep in mind. H you will be knowing. Just simply find H, H minus and P we are knowing, and H minus PV that you can use. Okay. If it is given, then it is very good. If it's not given, then we can. Okay. Okay, then anyone want to take that screenshot? You just try because we haven't find the final answers. Okay, in the next class, what we will be doing? Here we have finished the most of the part for the thermo. So from the next class, we will be only solving the problems, previous year problems and some good problems. I will take for the gate only. Now we will see like gate problems are very easier than this actually. So till now we have solved only conventional problems in each class, right? So now after this in 2-3 classes we will finish all the gate problems. So next class you tell the answer because I will ask. This is the homework for all problems here. This. So answer I will ask. Okay.
Sir, could you please show the homework again? Actually, I just got automatically logged out due to
Only this slide. You have to
poor
find the
network.
answer of these things.
So how do you find the pressure value after finding the drainage fraction?
No, pressure because you are
Constant.
sure na this is the point because it is in between between the liquid and vapor. So for it is the constant pressure line. What properties you have used? This properties only, huh? So pressure would be the constant for all, and pressure it is given here, na.
Okay, sir.
It is simple here. Okay. Should I proceed forward?
Yes, sir.
Yes, sir.
So I will be giving hint here also, and just first read the question and then we'll start. Give the hint and then we'll go to next question. Here it is asking for internal energy, right? Just keep in mind. And now they haven't provided the data of the U, correct? UF and UG, it is not here. Anyone solving?
Yes, sir. Yes, sir.
Okay. Then try. I will wait for 2 more minutes and then we'll start. If anyone seems like a value is missing anything, then let me know. Okay. Anyone can tell how you are proceeding?
Sir, H minus PV
For first
in
case you are
super.
solving. No?
Yes, sir. In superheated region, we have Hg and we have Vg, and we have pressure also. So H minus pressure multiplied by Vg,
So
and after getting
what you will get that point?
from there, I have got sir. I have a total result 5206.3 kilojoule.
No. Here is telling that you will do Hg minus PVG, right?
Yes, yes.
So this will you be knowing. Okay. After that, what you did?
I multiplied by mass, which is 2 kg.
Okay. Only this much you have done, right?
Yes, sir. For
Okay.
first case in superheated region.
After finding UG, we can add CV delta T.
So okay. Then we will start. So So you have to find the internal energy of the 2 kg steam at 25 bar when it is let's suppose it is 25 bar line. when it is superheated. First it is saying at 380 degrees Celsius, and it is showing like saturation temperature is 223, means this point is 223.99. Okay, and Cp it is given for the steam, it is 2.093. So what is the U is H minus PV, right? So this point what is H, but no superheat value is table is given here, so you have to find that value. What is the space enthalpy here, and Cp into delta T, correct? Hello.
Yes, sir. Yes, sir.
So Hg, what is the Hg? This one 2803.1 plus P. It is in the bar, so you have to units you have to keep in mind. Okay, bar we will be converting, multiply by 100 we will do, then it will become in kilopascal. So meter cube we will multiply, then it will be in the kilojoule. Okay. Hello.
Sir, there will be minus now.
Oh, sorry. So
So whether
no.
we
First
can use the
five
VG
I am
value.
asking about the enthalpy here, na. So it would be plus. It is only enthalpy part, because what would be it, just let's suppose it is A point, it is B point. Enthalpy at A you have to find first, na. Sorry, enthalpy at B you have to first find. Then what it would be? Enthalpy at A plus Cp into delta T. So enthalpy at A is this much, and Cp. Where is Cp? Oh, sorry. So you first have to find the enthalpy at B. Means this way we will write HB. What it would be? It would be the HA plus Cp and Tb minus Ta. Now it is correct, right?
Yes, sir. Yes, sir.
You have to tell na what I'm doing.
3129 आ रहा है sir value.
Okay. So HA is 2803.1 plus 2.093, and it is 380. 380 minus 223.99. So something would be coming. How much you are telling?
3129.6. 29.62.
So it is the enthalpy at this point. So you have to find the internal energy. Right? So you have to find the now what would be the volume here. This is the question. You know the volume here, right? Specific volume. Sorry. So what is the specific volume here? It is the constant pressure line. You know this, right? Constant pressure line. This is. So
V1 by equal to T1 by T2.
So you know PV is equal to MRT. Here constant pressure, so V is proportional to T. So VB by VA is equal to TB by TA. But one mistake you may commit here, because everything here given in degree Celsius. So convert that to the Kelvin first. Okay.
Yes, sir. VB is coming 0.10508. 105,086.
Anyone confirm this?
Yes, sir, correct.
Okay. So VB value we are knowing, and the pressure already we are knowing 25 bar. Now simply we can use U at U is equal to H, we are knowing this 3129.62 minus pressure is how much? 25 into 100. This got now why I multiplied by 100.
Sir.
Yes, sir. Yes, sir. To convert into kilopascal.
Okay. 0.105086. So after solving, how much it is coming?
2866.9.
answer, what is answer is coming? Hello. Any other? What is the final answer?
सर यही है.
This is the mistake point. Okay. This is kilojoule per kg. So we have to multiply by this.
Okay, sir.
Everything you will do correct, but at the end you commit mistake. Then what is the point of it?
So 0.1050.
What you are telling? Okay,
Specific
okay. You are specific volume telling. 0.105086. So multiply enthalpy minus pressure into volume. Pressure convert to the kilopascal. So after that,
So will the answer be 2610 or something like that?
What?
2610 kilojoule kg.
No. Multiply this with 2. So it would be 5600 approximate, I think. Sorry, 57.
Oh no, actually, I'm telling the total answer. Oh.
Total is how much? 57?
5733.82.
It would be the correct answer.
33.807. 33.
Yeah, enthalpy of B you are telling 33. What you are telling? Not getting. Hello? Someone is telling 33. What is this? Hello?
No, sir. I'm telling 33. That is it.
Okay. After.
No, 5733. That is it.
Okay. I see. Okay then. So second part it is easy, I think. So you can do it, right? Hello.
Yes, sir. Yes.
Yes, sir.
So, can we do it by individually finding UF and UG from HF and HG?
That way also you can do. Yeah. You simply make one column here this way. Here we extend this and UF and UG and then find easily. Correct? What will be the UF? HF minus P we are knowing and volume we knowing, right?
Yes, sir.
So something it would be coming here and something would be coming here and simply do this. Okay. Hello.
Yes,
sir.
Sir, even for the first one,
Huh?
even for the first one, we could have done this. No, sir. Like after finding UG, like we can directly do UG plus CP into TB minus T.
You are telling for this, na? First problem you are telling this way.
Yes, sir. First one also.
What you are telling? UG and?
For a superheated one, like after finding UG, we can do UG plus CP into TB minus T.
No. That way.
Sorry, I think we need to use CV. Sir.
No, CV also you can use now. How constant pressure you will say CV? CV where you use? It is.
So we can find CP.
Only you have to use enthalpy here. Because if it is saying like it is piston cylinder closed system, it is said, then you go like that. But it is not said here like it is closed piston cylinder arrangement. So enthalpy is point you have to go. Okay.
Sir, but here constant pressure is like not given. It's just given specific heat of steam. So I thought.
No. For the steam
Sir,
you have. Okay. What are you saying?
We since we can use CP minus CV is equal to that relation we can use and find CV and we can use that method also.
Here what
right?
you will write here?
Or CP by CV is equal to R 8.314. Can't we use
You
that?
are no. This is Cp minus Cv. We used to write here characteristic gas constant,
R,
right?
R,
R.
R, and this R value is R bar by m molecular weight. Huh?
0.4618.
Hello.
Yes, sir.
Uh-huh. So this you write, but it is, if it is not given, then directly we need not to switch. I think so. Huh? If it is given here,
sir,
then it is okay, because it may for the steam sometimes it not they are considering it is not following ideal gas equation. Uh, it is for the ideal gases we are doing, right?
Sir, but here it is written that it is this steam is
Perfect gas
behaving
it
as a
is
perfect gas.
written, then we you try. If
And
it is coming same, then let me know. Next class.
sir,
but sir,
one thing
here
also
gas is
that
also not given.
Because if
Which type
it
of
is
gas is
written, then it is
given?
okay, it may follow, but generally you make not a rule like this. Okay, we will do like that. Huh?
Sir, but this is R bar upon M. This M is molar mass, no? So, sir,
Molar
here
mass, molar
it
mass.
is not written. It is not written that that which type of gas it is,
No, no.
which gas,
If
which
they are
one.
saying steam, then we can consider it as water. Okay.
Okay, sir. Okay.
So 8.314 divided by 18, right?
18.
H2O 18 would be there, right? So it would be the R. Just to try it is coming or not. Let's see.
And sir, one thing more, sir, that here it is written specific heat. Sir, how do we know if the CP is given or CV is given?
Generally, specific heat at constant pressure they will give here.
So
Properties of
we
process.
can
So
assume that it
directly,
is
either they will mention like a specific heat at constant volume. It is they are going to give. Hmm.
okay.
Sir,
It
by
is
the method,
conventional question, so they used to not give that much. So you have to consider in assumption you can write like it. We consider this is specific heat at constant pressure. So it is okay. For the gate problems, they will specify clearly.
Okay, sir.
So in conventional, you have to write assumptions like we are considering this as a specific heat at constant volume. Okay. So next class, this is the homework. Okay. You find, because you know the process how to proceed for this problem. This is the most
Okay.
important here.
सर
Okay, sir.
by the
हाँ.
method of CP minus CV, मतलब वो सर CV वाले तरीके से किया तो 2857 आ रहा है U
You how much?
2857 आ रहा है
Okay, okay. So
अंतर
close to same, no?
ये सर
2857. Okay, then try. I will also see, and next day, we'll discuss next class. Okay, this time, because we have to solve more questions here. It would be better. This problem you see, no? This is the I want to solve. Just try to see this problem once, and then we'll start. It is visible, right?
Yes, sir.
Yes, sir. Yes.
Okay. Just read, and if anyone like understood the problem, then let me know. Just explain the problem. What is it? What it is?
Sir, could you please explain this part? The piston is free to move till the stoppers at the top. I mean, would it
This
be
time
continuously?
making three schematic diagrams, and then try to solve it. So
Okay,
the
sir.
piston contains 3 kg of the weight steam at this pressure, and the initial volume it is given 2.25 meter cube, and the system is heated until the temperature is 400 degrees Celsius. Piston is free to move till stoppers at the top. Means it is piston cylinder arrangement. It is clear, right? And there are some stoppers at the top. Let's suppose this is. And this time volume of the cylinder is 4.65 meter cube. Means initially it is 2.25. Means till the stoppers volume is 4.65. And initial volume is 2.25. Means initially it is here.
Sir, initially means the condition at 1.4 bar.
Start of the process. Start wait this is this is the first condition. So something is here. Okay. So next what happened? System, we provided some heat to the system, and now it has reached to till the stoppers. Here it will come. Okay. Hello.
Yes, sir.
So till here, start from here. Here pressure is how much? 1.4 bar, and till it reaches here, initially it would be the constant pressure process, right? Because here some resistance is there, so it is resisting. But here inside pressure would be same. It will, as he will provide heat, so it will just simply go up and start touching here. Correct. So till that point, it is constant pressure process. Means volume here volume is how much? 2.25 meter cube, and here pressure is 1.4 only, and volume is 4.65 meter cube. Let's suppose this is the second. Now again they have said like now stopper, now piston will not move, and but we are providing heat till the temperature is 400. Means after this process is the constant volume process. Correct.
Yes, sir.
Are you getting what I'm saying? Others?
Yes, sir. Got it.
Hello.
Yes, sir. Yes.
So constant volume process till pressure is they haven't mentioned here, but in the steam table they have mentioned like pressure is this 2 bar. So we will say pressure is 2 bar. So volume is same 4.65. Is it clear or not?
Yeah, it's clear.
So now just think once, because this is the last question we will solve, and rest 2-3 questions I will be giving for homework. Those are the easier ones. This if you are able to solve, then all are okay. Just think once more and then we'll start. Anyone try?
Hello. Since V initial is given, we can find specific volume at initial state.
Okay.
Then also the final volume is given. V3.
With the
That
initial
is
volume,
equal to
what
V2.
information you got?
With initial volume, we can get the specific volume.
Okay.
Then we can find the final volume. So which is equal to V2 and V3 because it will be constant volume. Then we can, since the then for the when it reaches the stopper, since it will be constant volume, we can use P2 by T2 relation and find pressure.
Find pressure.
Find the final pressure P3.
But okay, pressure is constant there, na? P 3.4 saying for what? Here pressure is defined right, 2 bar. Not getting. Actually, what you have to find in the problem? You have to find the amount of the work and heat transfer.
Okay. Sir, work will be P delta V. P will be 1.4 bar and delta V will be 2.4 meter cube.
How you are solving this? Okay, let me start, and if in between any doubt, let me know, huh? It would be better. So just I will explain here first. What
Sir, for this wet steam, we have to consider in wet region or this vapor, liquid vapor region.
If it is a mixture of both, then in between also you have to consider, na? So first we have to find the specific volume at first. Let me start. Huh? So how much it is coming? Anyone solve? 2.25 by 3.
0.75.
Okay. 0.75 meter cube per kg. So from this, what you have got? Like VF it is given or not? Oh. Okay, VF anyhow it is very less for the water. Huh? It is close to, because density is 1000, so it is close to 0.00 something. So we can neglect that part. So Vg you have to consider here. So Vg is this, and here V1 we have got 0.75, means it is in the wet region. Okay, one TS diagram I will start here.
But can't we use P delta V, like the general formula? Pressure is constant and volume is changing just.
Okay, after that first, because it is what I am thinking, like it is a constant pressure process. So because work you can find, but heat you have to find here also, na?
Yes, sir. Heat we have to
For
find.
that point of view I was starting.
Okay.
So okay, this is the dome. So let's suppose this is the, it is the point here, because we found like it is 0.75 meter cube per kg. Hello.
Yes, sir.
So anyone found x here from here? Now if here that VF it is not given, so we will consider like relative to this 1.2363, 0.001 something is very negligible. Okay.
Dryness fraction is 0.607.
Okay, that I will see. But you, that assumption you got, na, what I'm saying? Why we are neglecting this VF?
Yes, sir.
So anyone found the, what is the dryness fraction here? Means
Yes, yes, sir. Yes. 0.607.
anyone confirm?
Yes, sir.
Okay. So now we have the value of dryness fraction. So now we can easily find the enthalpy, right? Because all properties we can find at the point 1.
Yes, sir. Yes, sir.
So
1820.
that we will whatever we need, we will see later. First we try to figure out what are the processes involving here. So from here at constant pressure it is reaching till this. Hello.
Yes, sir. Yes, sir. Yes, sir. Got it.
So you can find
Enthalpy.
Sir, enthalpy is coming 5,439.5.
Yes, sir.
enthalpy at this point, right?
Yes, sir. Yes, sir. 5,439.5 kilojoule.
H1 is what? 5439.5
kilojoule.
So two
Yes,
people
sir.
are saying, so I will considering it as correct. Okay.
सर मेरा तो 1812 आ रहा है.
नहीं.
How that will come?
It would be like more than 1800.
Also multiply with this mass also, huh?
3. You perhaps missed the mass 3 kg.
सही है.
So you also will be knowing, because it is the closed system, right? So for the closed system, work done would be the first what would be the specific that
Sir, your voice is getting low. Could you
Hello.
please repeat it? Yes, sir.
Hello,
Now
hello.
it's. Yes, sir. Yes, sir.
So total internal energy, you can tell what is that internal energy? Because we will simply subtract with total heat interaction with the, when we subtract internal energy change, it would be the equal to the net work done. So that way we are trying to solve.
नेट वर्क डन तो डायरेक्टली फाइंड आउट कर लेंगे ना P delta V से.
That way also we can go. That was second method. Second method we can say that. Okay. First we will go with this. What is the U1 here? Because UF, UFG you are knowing. So let me know.
5124 kilojoule.
5124. Any point? A value here.
Kilojoule.
Hello.
Yes, sir.
5124.
Kilojoule.
0.3 kilojoule.
Okay. So we are knowing this. So now what is happening here?
Internal is changing.
So what is the specific volume here? 1.2363. But let's suppose this is the some point B here. And what is the specific volume at this condition? Anyone found?
1.55.
By 3. How much?
1.55
1.55 meter
Meter
cube per kg.
4.65 by 3.
So what does it signifies? It signifies like it is in the superheated region for this 1.4 pressure, correct? Because till here it is the constant pressure process, correct? So simply you can means it is here some point it is here means 2 point 2 point would be here, correct? Getting or not getting?
Yes, sir, got it.
So all the properties we have to find here at 2. Means what is the H2? H2 simply we can find, right? Because we know the value of HB and Cp into delta T. But what is the temperature here? Getting na? How we are proceeding?
Yes.
Because we know the specific volume here, and constant pressure process, so temperature easily we can find, right? V is proportional to temperature for the constant pressure process, correct? So T2 by Tb is equal to V2 by Vb, and we know all values, correct? Hello.
Yes, sir.
So anyone, what is the value of T2? Convert this value to
Sir, here T2 mean degree of the superheat or like that?
T2. No, I am saying about what would be the temperature here. Where is the cursor? Here.
T2 तो 400 डिग्री सेल्सियस.
Hello.
सर T2 तो है ना 400 डिग्री सेल्सियस.
No, it is not T2 na. Here pressure till 2 bar, but here pressure is only 1.5 bar, 1.4 bar. So now here after we will increase constant volume process we will do. Okay. Hello.
Sir, it's coming 137.05.
What?
137.05 it's coming.
Degree Celsius.
So
Anyone? What are you saying? 130?
oh, sir, I think
469 Kelvin. I'm getting 469 Kelvin.
469 point any value?
469.38.
Okay. I'm just giving hint how to give, and let me after calculating let me know. Huh? Means here V2 what you are V2 you are putting 1.55, right?
Yes.
And
Yes.
what is the VB?
VG value.
VG value 1.2363, and simply multiply it with TB. TB means this plus 273, correct?
Yes.
So this plus 273 how much?
469.38
okay,
Kelvin.
something would be there. So this would be this. Just anyone, one more person, just confirm this value.
390.
Yes, sir, same value.
Okay.
466.
469.54,
sir.
Okay, that 1 to we can manage. So more people getting 469 or 466?
It's 469, sir.
Okay, fine then. So now simply we know that value of T2, TB, and means delta T we are knowing here now. So what is the value of H2? Someone calculate. Because HB we are knowing, CP it is giving here. So what is the value of H2?
At 2 bar.
This here only, this point.
Okay.
Delta T you know, and CP you know, HB you know. What is the value of H2? And the same way someone find U2. Getting my point or not?
Yes, sir.
Okay.
So will it be near about 9,000, like 8,009?
Yes, sir. It is coming as 9,029.9.
Yes, yes, yes.
So 0.0673 into anyone converted this to degree Celsius? T2
196 196 कुछ आ रहा है सर 196 सर
196.33 then.
23 हाँ 3 होगा 33 की बजाय 23
273 73 will subtract na.
Okay sir.
So Cp and this minus this T saturation. Anyone did?
Yes, sir.
Hello, sir. One doubt. Sir, 5439.5. It should be HB value, right?
Oh, sorry. Here it is correct. 5439.5. Here it would be
on the
this
top
plus this.
Yes.
Sorry. So how much is it? 2231. 2690.3, right? Hello.
Yes, sir.
Yes, sir.
So after delta T you did this, this minus this. So how much it is coming? Hello.
Yes, sir. Just
8,609 kilojoule.
Okay, after multiplying with 3 now.
Yes.
8,000.
609.9.
Okay. Same way we found H2, U2 we will do. Okay. Hello. You will be finding like H2 minus here directly we will use that equation. Okay. P2 we are knowing same pressure and V2 we are knowing directly we will write 4.65 right here, so it will come. Getting what I'm saying? Hello.
Yes, sir. Yes, sir.
So tell what is the value of U2 here?
Okay, just give me.
7958.9.
79.
58.9 kilojoule.
Anyone? One more people calculate.
No, sir. I'm getting more than that.
How much? How much we are getting?
Sir, it's about near about 10,000, like
How it will be?
9,000 and.
It should
Yes,
be
sir.
less than H2, na? H2 minus something we are doing. One minute, I will.
Okay.
Sir, I have a doubt, sir.
Hmm?
Sir, what's the value of V2 here in the right
In
formula?
U2, na?
No, no, V2, V2.
In U2 equation, you are asking about V2, na?
No, sir, in the equation T2 by TB, V2
Okay,
by
okay.
V.
This specific volume we are taking. This one
This is
1.55.
1.55 and VB is VG, right?
VB is yes, VG. This 1.2363.
And TB is just, sir, by this value, I am getting T2
Ah.
479.33, sir.
Oh. Anyone calculate again, because if it is wrong, na, then we are doing same. That's why I am saying two, three people just clarify. Just one people more. Is it 469 or 479? I think it's
Sir, it's 469.
1 minute. I will be doing. It should be 479.33. Huh?
Yes, sir.
.33 Kelvin. So 479.33 minus this. How much it is coming? 1 minute. 109. So 479.33 minus 382. So into this CP value and plus HF. You tell how much it is coming? Hello.
Yes, sir.
You consider this, and here I will be writing. Just calculate and let me know how much it is. I am also doing, so we will confirm what is it. 382.32. Just tell the value of this.
So after multiplying by 3, we get 8672.54.
Starting it is coming out. Two eight nine zero it is coming, right?
Yes, sir.
2890.8 to 3. 8672.4. 8672.4, correct? Multiply this by 3. This multiply by 3. Hello?
Yes, sir.
Is it coming or not?
Yes, sir. 8672.54.
8672.4. So H2 we are knowing P2 is 1.4 bar. So convert that to kilopascal, and V2 put this whole volume 4.65 because it is whole volume here. Na? So how much it is coming? You tell that value.
So 7742.54.
1 minute. How much you are telling? 77?
42.
42.54. Anyone is doing, other people, or should I do? We will solve first and then I will explain again, okay?
Sir,
Some error is coming in between calculations, so that's why it is taking time more.
sir, here we will consider for pressure at P2 equal to 2R.
Till now that point we haven't reached. We are only here only as of now. This point only we are as of now, right? We haven't reached here because we are doing mistakes in between. So as of now at only we are at P is equal to 1.4 bar only. So we are calculating the values here. So after that it will go up. I think this value is also wrong. I am calculating, then it is coming like 8021.4. Pressure you have to take 1.4 because it is constant pressure line. 1.4 pressure is here. H2 this value you take. Pressure 140 means a kilopascal, you convert this 1.4 bar to kilopascal 140, and V2 take 4.5. Then it will come 8021.4. Confirm this.
Yes, sir.
So lot of calculation mistakes are going on. So what we are knowing here, from here to here it is constant pressure process, right? Means point 1 to point 2.
Yes, sir.
So for the constant pressure process, we know the difference of enthalpy is the heat given to the system, correct? Hello.
Yes, sir.
So heat given from 1 to 2 is H2 minus H1, correct? Hello.
Sir. Sir.
Yes, sir. Yes, sir.
So some value would be here. So how much it is? And we know the change in internal energy from 1 to 2. How much it is?
3775.8.
1 minute. Subtract H2 minus H1, okay?
Yes, sir.
8672.4 minus 54.9. It is 3232.9. What you are doing? H2 minus H1, right?
Yeah. 8672.4 minus 86.
3233 H2
हाँ
minus H1.
कितना
3233.
3233
33.
and similarly U2 minus U1
Sir, it will be 2897.1.
how much
2897.1.
okay so from the first law
Yes,
of
sir.
thermodynamics what is del Q is equal to del U plus del W so from here what del W we will get del Q minus del U this is del Q minus del U so simply this minus this how much it is coming 35 approximate I think so sorry 300
335.99.
uh, this kilojoule so we are getting this from here because after that what will happen after that for the work here a constant volume process after that in the constant volume process no work done right so for the work here two things we have to find the amount of the work and heat transfer work we have found like this is the work for the first case so it will be the our final answer for the work but heat again at the constant volume process we have to add heat right
Yes, sir.
so that
Yes,
part
sir.
we have to do again so this way I was thinking so because actually in between lot of calculation mistakes are there so it has taken time right
Sir, if as such problems as given on the gate, then that might be
no in
time
if it will be
consuming.
coming at na it would be like it would be 2 3 questions in one question so it would be worth 6 marks
Oh,
so
for this question, there would be 6 points, right, sir?
6 marks means some you in the previous year you will see like some questions are like in paragraph they will write and 3 questions they will ask one by one
Okay, 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 sir.
so one question won't be that because that's why I used to take conventional problem there you will come with the 4 5 types of problem in one problem only so next part we will start this part anyone has doubt then I will explain again actually so first point it is clear like it is weight here we have found the dryness fraction so it is here so but after that we have provided heat and it has reached the stopper with this pressure so with this pressure and this is the saturated point but when we calculated the specific volume for this when it is touching the stopper it is 1.55 we know here Vg is given as 1.2363 so it would be 1.55 more than so it is superheated state we have calculated because we know the it is the constant pressure line so we have found the temperature here first and after finding the temperature we found the enthalpy and the uh, internal energy and along with enthalpy we are finding internal energy because it is we have to find the work done and work done is the difference of the enthalpy and internal energy right but now coming to the from here to here what process is there constant volume process right 2 to 3 let's suppose this is the stage 3 getting or not getting
Yes, sir.
Yes, sir.
so from 2 to 3 constant volume process and here for the constant volume process work done would be the 0 again we will write del q is equal to del u plus del w and here work done would be 0 right so what amount of heat you have to give in it would be the change in internal energy correct hello
Yes, sir.
so here they have provided like 2 bar pressure temperature is 400 means you have to reach till 400 degrees celsius right here only Hmm? and 400 they have provided and it is the superheated state and it is also superheated we know so something like this will be going here and it would be connecting here somewhere this state it is 3 So we are knowing H here, and you have to find the difference in the internal energy from where to where, 2 to 3. Huh? Hello.
Sir.
So how you will find? Hello. Actually, need not to find, it is given already here. Correct. If it is not given, then you have to do like H minus PV. Pressure it is 2 bar, and volume it is here. Like that you have to go again. Hmm. So but enthalpy, internal energy directly given, then directly we can write. Means U3 minus U2. U3 3 times of this value, 2967.2. 2967.2, and minus U how much? U2 8021.4. 8021.4. How much it will be coming? Whatever value it is coming, that will be the our del Q for 2 to 3. How much it is coming, anyone?
Sir, 880.2.
880.2.
Yes, sir.
Okay. In plus na sign.
Yes, sir. Plus.
Okay. So net heat we have, what we have to give? Del Q net, Q from 1 to 2 plus Q from 2 to 3. So Q from 1 to 2 is this, and Q from 2 to 3 is this. So add this, and this would be the total net heat transfer. This is our next problem. Amount of the work and heat transfer. Work we have already found. This would be the work, and what would be the heat transfer? This would be the heat transfer. Got it or not? Question wise it is
Yes,
not
sir.
that
Yes, sir.
tough, but we have did a lot of mistakes in between. So how much it is coming, final answer?
4113.2.
Point
2.
this is 4115 it is coming. Okay. So this is a bit you can try this problem again. I think any problem now, or is it okay?
So I have to look upon it. So have to look on that problem once again because
Uh-huh. I will explain again.
okay, sir.
So some people is saying like we will find the network done as P delta V, right? So when you try that way also it would be coming, because it is constant pressure process, and volume, initial final volume we are knowing. Initial volume is 2.25, and final volume is 4.65. So simply subtract, it will become 2.4. 2.4 into 1.4. That means 140 into 2.4. How much it will come? It should come around this only. Minus 24,336. Approximately near to same value. So that way also you can go, but this way, both ways you can try. No issue. Okay.
Okay, sir.
So just you, anyone have doubt? I will start again, or otherwise, I think for today it is fine. Next class we will solve only problems. Previous year get problems. Next class we will solve. And I think. In this problem, I will just quickly give hint and you try. Okay.
Okay.
So a mass of wet stream at temperature temperature 165 is expanded at constant quality of 0.8, means Ts expansion is happening. Expansion means what? Higher pressure to lower pressure we are coming.
Lower pressure, yes, sir.
So this is P1, this is P2. So they have told like we will say this is the constant quality line. Okay. 0.8. Got it or not?
Yes, sir. Yes.
Means X is 0.8 for all this.
X.
So 0.8 and 3 bar. Expanded at quality 0.8 to pressure. So means so first it is at this pressure means 165 they have told. 165 means 7 bar. Pressure is 7 bar here and here 3 bar it is coming. Okay. So this way you have to come. This is the first point, this is the second point, and then it is heated at constant pressure to a degree of superheat of 66.5, means after this reaching here again it is started heating. Degree of superheat here what temperature it is? 133.5, and the degree of superheat it is given as third point is T3 is equal to simply add 66.5 here, means 4 200 degrees Celsius it will become, right?
Yes.
Hello.
Yes, sir.
So find the enthalpy and entropy changes each during expansion and heating. Means you have to find a value of H and entropy here, enthalpy and entropy here, and enthalpy and entropy here. That's what I in the start I have told how to calculate these things, right? Because temperature we are knowing everywhere, here, correct? Hello. And simply draw the TS diagram. Diagram I have already drawn, and TS diagram of the same, and Cp of the steam as 2.093, and here you need Cp for the calculation, right? So they have given. Use the following table. This table you have to use and find. This is the homework, okay? Got it or not? What is the
Okay.
problem?
Yes, sir.
You can. This problem is a bit easy. You can solve that last problem. This is the important problem, so that I took first. So just take the screenshot and then we'll discuss in the next class.
Have taken, sir.
Okay. Others, if you are fine, then take.
Sir,